Hi there, my name's Professor Deborah Davis. I'm Professor of Midwifery at the University of Canberra here in Australia. So this session is following on from a PowerPoint or a YouTube video that you've just watched on calculating odds ratio and interpreting odds ratio and relative risk. I've put some worksheets up for you to practice on, and this session is going to take you through the answers so you can check on how you went. We have two examples and we'll just look at odds ratio for the moment. So this should be the worksheet that you've completed. It's a pretend study of a new drug called No Marks Max, and we wanted to see whether that was effective at preventing stretch marks. So we had 120 people in the study altogether. 60 in group A and 60 in group B, so that makes it pretty simple. This is the total number of women in group A and the total number of women in group B. Now we worked through these 2 by 2 tables in the presentation that we hopefully you saw on relative risk and odds ratios. So what the results were of the study that we're going to plug in here is that in group A, the women who got the new drug, 12 women developed stretch marks. So we'll put that here in group A. Hopefully that's what you had. So therefore we know how many didn't get stretch marks because we just take the 12 away from the 60, so that we know that 48 women didn't get stretch marks in this group. Now if we come down to the group who didn't get the drug, this is group B, what did we find up here? 10 women in group B got stretch marks, so we'll put in here. Didn't get the exposure to treatment, group B. Did get stretch marks, we had 10. So we can work out what goes in here, that's 50. Hopefully you're with me. Okay, so we can already get a bit of an idea. We've got the same number in each group, the 60 and the 60, and we can sort of get a bit of an idea, can't we, of whether we think this drug was going to be effective. We actually had a couple more women getting stretch marks in the group who took the drug than we did in the other group. But let's go through and work out an odds ratio. Here's the formula for you. A divided by B, which are these cells, and that whole thing is divided by C divided by D. So if we work out, first of all, this would be the experimental event rate, or how many got the event in the experimental group. And we know here it's 12, and we're dividing that by 48. That's A divided by B. And if you calculate what that works out to be, you should get 0.25. Now the control event rate, or C divided by D, which is 10 divided by 50, goes in here. We have 10, and we're dividing that by 50, and that works out to be 0.2. So remember, now we have to do this A divided by B, which is the 0.25, and we have to divide that by C divided by D. So that goes in here. And if you do that calculation, you should get 1.25. So how do we interpret that finding? We've calculated an odds ratio of 1.25. So what that means is, because that number's greater than 1, we know that those receiving the treatment have a greater chance of developing the outcome, which is stretch marks, and that's because the odds ratio is greater than 1. How much greater chance do they have? Well, you remember that 1 is the line of no effect. It makes no difference. So how far away is this from 1? It's about 0.25, which is actually 25%. So we can say that they have about a 25% greater chance of developing stretch marks than the group who received the placebo. So I hope you went well with that example. We'll go through one more. So this next pretend study looked at rural telehealth support. And it was set out to investigate whether a new telephone support system for rural women was effective at preventing maternal anxiety in the antenatal period. So we've got 100 women in total in this trial, 50 in each group. So we have 50 in the group who were exposed to the treatment and 50 in the group who didn't get the treatment. So what did we find? Group A, who did get the treatment, we found 3 women here got the outcome, which is anxiety. So that means we can work out how many in this group didn't have anxiety. It'd be 47. And in group B, the ones who didn't get exposed to the treatment, we found that 6 in that group got anxiety, which means we've got 44 in the group who didn't. Okay, so let's, we've got equal numbers in each group. Let's just have a look at what we think we're going to find. We've got more women getting the anxiety in the group who didn't get the treatment. So, we can already start to intuit that it probably had some positive effect, and we'll find an odds ratio that reflects that. So let's go down and put the numbers in to work out the odds ratio. So remember, it's A divided by B, and that is 3 divided by 47. And if you do that calculation, you should get 0.064. Depends on the exact result you get, how many decimal points you round to. But if you round to 3 decimal points, you should get the same as me. Then B, we've got 6 divided by 44. 6 divided by 44, and if you do that calculation, you should get 0.136. So then we've got to take that calculation and divide it by that calculation. So we've got our 0.064, and we need to divide that by 0.136. And if you do that calculation, you should get 0.47. So that's the odds ratio. So let's interpret that now. You can see that those receiving the treatment had less chance of the outcome because this odds ratio is less than 1. So how much less chance did they have? We need to remember 1 is the line of no effect, so we really need to say 1 minus 0.47, which is 53? 53% less chance, almost half the chance of developing anxiety than the group who didn't receive the tele support. So I hope you went well in those worksheets, and I hope that you'll join us, or if you haven't already, on the worksheets calculating relative risk. Thank you.